This is section 1-4, and we are going to simplify algebraic expressions. So we're going to do some translating words into algebraic expressions. So I'd like you to take a look at some words that represent the 4 different operations. Let's start with the addition. With addition, we can say sum. We can also say total. We can do combine. And with subtraction, some words you could use would be difference, less than, decrease by, and then let's go down to multiplication. We can use product, times, and division, one would be quotient. Now there are other words that you can use for those operations, but those are just a few examples. And now we're going to translate words into algebraic expressions. So I have a couple of examples down here I'd like you to look at. And the first one is the cost of C containers of ice cream at $2.79 each. Well, off to the side here, if I have one container, it's going to be $2.79. If I have two containers, or $2.79 times 1, if I have two containers, it's $2.79 times 2. So for any number, all we need to do is take $2.79 and multiply it by our cost. So this would be $2.79C. That would be the expression that would represent that problem. Now, the next one is the number of cards N in a deck after N cards are removed. Now, some people will do this. They'll go, oh, okay, it is N minus 52. Well, you only have a total of 52 cards, so it should actually be 52 minus N. So be real careful when you're setting those expressions up. Especially if it's subtraction. Subtraction is not commutative like addition and multiplication. So keep an eye on that. Okay, the number of days in W weeks. Okay, well, if we had 1 week, how many days would it be? Well, we know that we'd have to multiply it by 7. So we're going to take however many weeks we have. So if it's 2 weeks, we still multiply by 7. So we'll take the number of weeks and we'll multiply it by 7 for an expression 7W. All right, let me just erase this part down here. Now, the order of operations, you have gone over this since you started doing algebra, and I just want you to kind of take a look at what we have down here. See if you get the same result if you do things out of order. If you wake up, eat breakfast, shower, and get dressed, and then brush your teeth, you're pretty much ready to walk out the door. If you wake up, eat breakfast, brush your teeth, get dressed, and shower, you are going to walk out the door very wet. Same tasks that you're performing, just in different order. Same thing that happens with algebra. If you perform the task and you don't use the order of operation, you're going to get a different result. All right, now if you look at the next page, the order of operations are used to evaluate algebraic expressions. And very important that you use the order of operations. You can use this sentence to remember, please excuse my dear Aunt Sally. Some people may just say PEMDAS. So if you write that off to the side, PEMDAS, I want to make sure you understand that multiplication and the division have the same priority when you read from left to right. So if you have something where you have division first and then multiplication, whatever order it's in, go from left to right. And then addition and subtraction, it's the same thing, same priority from left to right. All right, let's look at the example here. I'm putting a square around all of the A's here because what we're going to do is we're going to replace the A's with 5. We'll replace the B's with 2. And listed here are the steps that you need to follow. Slide this over just a little bit here so you can see the whole thing. All right, so they've already written out 5 squared. They replaced the a with 5. They replaced this b with 2. And then we just need to write the minus 3 times 5 here. Okay, now they're telling you the steps. Very first step you need to do is evaluate the exponent. So that's the only thing we're going to do on the first blank. 5 squared is 25. We're going to leave the 2, the 5. 2 squared is 4. And we're going to leave this because we're only evaluating the exponents. Next step is we need to multiply from left to right. So we're not going to do anything with 25, but we are going to do 2 times 5, which is 10 times 4, which will give us 40, minus 3 times 5, which is minus 15. And then after we do that, we're going to add and subtract from left to right. So 25 plus 40 will give me 65, and then I subtract that 15, I end up with the number 50. Okay, you're going to do 2 and 3 on your own. And let's just go to the next page here. You're going to also add and subtract the coefficients. So just the coefficients, I'm going to circle that, of like terms to simplify an algebraic expression. Now, like terms have the same variables to the same power. So since this is x to the first power and this is y to the first power, x to the first power, y to the first power, those are like terms. Also like terms here, 3x squared, 4x squared. We don't look at the number in front here. We only look at the variable and the exponent. Okay, now this is a constant, and it's pretty easy to know that you're going to add the constants together, add or subtract. Okay, so they're showing us how they are combining like terms here, and they listed the like terms, and they're lining, this is the original question that you started with. They grouped the like terms here, and now they're putting them in order. So these are now like terms right next to each other. So what we're going to do once we know they're like terms, we only look at the coefficients, the values in front of the variables. So the 3 and 4 will give us 7, that's x squared. And 5xy, there is a 1 in front of here. You don't have to have a 1 written, but it's automatically understood that that's a minus 1. So we add 5 minus 1, we'll get plus 4xy, and then plus 2. You can also use the distributive property to simplify algebraic expressions when you need to. And here they're just showing you, and this is one of the properties that we went over in section 1-2. You distribute, and then you combine like terms. Here you end up with a negative 2a squared here and a positive 2a squared. So we put those together, and these are like terms. We put them together, and again, only add the coefficients. The variables stay the same because we're only adding. So these will turn into 0. 2ab plus 6ab is going to give us an 8ab. So let's try this one down here, number 4. I've put boxes around the like terms. They're like terms because each one of them has an x to the first power. So these will get combined. I lined them up with like terms, so minus 6x, minus 2x, plus 4x, and then we have that constant plus 3. That's grouping the like terms. And then we're going to add or subtract. So only the coefficients. Minus 6x minus 2x will give us a minus 8x, and then we add 4x to it. That will be a minus 4x. And then we add 3. Now, we can't combine those any further, so that's all we can do. All right, now you're going to finish up the 5, 6, and 7 on this page. And also remember you need to do the 2 and 3 on the previous page.